Yeah, it's time to practice some equation solving. Let's do it. So we're going to solve each equation. We're going to use the idea of undoing the operation that is being done to each variable. So these would be considered solving equations that involve addition. So let's jump right into it. This first equation says 16 equals 3 plus m. I recognize that oftentimes people are used to having their variable on the left-hand side of the equation along with the operation. No sweat if the variable is on the right-hand side. We can do a couple things to alleviate this. One, you can just solve it as is, and that's what I'm going to do, and then I'll show you another way that we could have done it. So I'm looking at this saying 3 plus m is 16. How do I undo a positive 3 from that side? Undo a plus 3? The opposite of plus 3 is subtracting 3. So I'm going to subtract 3 with the perspective of I want to undo that. But whatever I do to one side of an equation, I must do to the other to keep the equation true. So I will subtract 3 from both sides. Now, 3 minus 3 is 0. I actively think about that so that I'm recognizing that I am left with m, that m is not just a matter of course, but that we got there by taking away 3. Then I look at the left-hand side and I'm subtracting 3 from 16. 16 minus 3 is 13. I like checking my answer, so I'm going to do a check here by evaluating my answer back into the original equation. So I have 16 equals 3, and I'm now going to evaluate in for the m value the number that I got. And sure enough, 3 plus 13 is 16. Now I mentioned to you that I'd show you a different way of setting up this equation if you're uncomfortable with the variable on the right. You can switch the order of things. We could rewrite everything as m plus 3 is equal to 16. This is the same as this. Whether I add 3 to m or m to 3, 3 plus 4 or 4 plus 3 both give us 7, we can do either order. And whether I say that you have the same amount as I do, or I have the same amount as you do, right? 16 equals everything, and everything equals 16, doesn't matter. It's still the same equality. So we would go about solving it the same way, subtracting 3 from both sides, just like we did before. And then 3 minus 3 equals 0. They cancel out. And you're left with m equals 16 minus 3, which is 13. So an alternative way of doing things. All right, let's check out this next equation. Here, I wanted to show you that we have problems with decimals. That doesn't change what we do. We have a number plus 3.6 equals 4.3. We want to undo plus 3.6. How do we undo plus? We subtract. So when I subtract 3.6, that will zero out. I must do the same subtraction to both sides of the equation to keep it a true equation. 3.6 minus 3.6 is 0, leaving us with just the x term. Now what I like to do here is, I like to do what I call a side quest, where we do a little bit of math off to the side and then input our solution in here. It's kind of like if you're playing a video game or watching a movie or reading a book and there's a little bit of a side story, you keep your mind on the main story, solving the equation. But you do this little side work just to kind of see how the puzzle pieces fit together off on the side before you put it back into the main puzzle. So you've got that love story that's going on in a movie, but off on the side, within the love story, there's a little mini story like, I don't know, the couple goes and buys a dog. Clearly I'm not a good movie director for other things besides math. Anyway, the idea here is let's do this off to the side. So I'm going to do the work right here. So let's do it 4.3 minus 3.6. We focus only on that. So when I'm subtracting those decimals, I realize that I need to borrow from the 4. And that makes that 3 a 13. I'm going to subtract 13 minus 6 is 7. Remember, we need to keep the decimal point right where it was. 3 minus 3 is 0. And so our answer for x is 0.7, or just 0.7. As far as doing a check is concerned, you take this value and you evaluate it into the original expression. So 0.7 takes the place of x plus 3.6. And the question is that equal to 4.3? It is. 0.7 plus 3.6 is indeed 4.3. So we have that both sides of the equation are equal. Perfect. All right, last but not least, we've got 41 plus g equals 86. Now, does that really change what we do here? No, not really. I know that the ordering's a little bit weird, but you're looking at how to undo positive 41. We would subtract 41 from both sides because, again, you need to do the same operation to both sides, and we want to undo plus 41. 41 minus 41 is 0. That leaves you with g equals, you can cross that out, but it's not canceling, it's equaling 0. 86 minus 41, let's do a little bit of side work. Let's do it right over here. So 86 minus 41. If you take a look at that, 6 minus 1 is 5. 8 minus 4 is 4. And so our answer is 45. Of course, you want to check your work. You want to make sure that you're right. So you take g equals 45, plug it in to the original expression. We are replacing g with 45. So 41 plus 45 is equal to 86. And that is a true statement. 4 plus 4 is going to give you the 8 in 80. 1 plus 5 is 6. It is a true statement. So y'all, solving equations with one step, undoing addition with subtraction. It's huge stuff, but it's simple. And it doesn't matter how the equation is presented. It's all about keeping your wits about you and just asking yourself, what do I need to do to undo the operation? In this case, addition. So I have to undo it with subtraction. And I have to keep in mind that I need to do the same thing to both sides of the equation to keep the equation true. Go rock some more equations, peeps.